So for section 11.3, we're going to be using the quadratic formula. I know some of you are like saying, finally. But I'm going to encourage you that actually these questions, first of all, to use quadratic formula, must be in standard form. So ax squared plus bx plus c is that equal to 0. And then when you do it, you plug it into this entire formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And a lot of you don't do this, but I recommend, because there's going to be a lot of mistakes in this with some of the arithmetic. So I recommend actually putting all those letters in parentheses. It helps keep track of the negatives, helps keep track of what's multiplying, what to do first. So you don't have to do that, but I have found that my students have more success with that. But before we do it, I do want to encourage you again that I would not be doing this unless I have to. Because there's a lot of simplifying that has to go on before I can use the quadratic formula. And then even with that, after I plug it in, there's a lot of simplifying that has to happen. So I would check and see if it can factor. If it's a simple factoring, do that all day long, or even AC, depending on your comfort level. If this could factor, that's how I would handle that. So my A is 6, my C is negative 4, 6 times negative 4, negative 24. My B is negative 5. So are there two things that multiply to make negative 24 and combine to make a 5? Well, 1 and 24, 2 and 12, 3 and 8. 3 and 8 all of a sudden popped out at me. 3 and 8 could make a negative 5 if the 3 were positive and the 8 were negative. So this could actually factor. And I would argue that that is an easier process than going through the quadratic formula. But I'm going to go ahead and go through the quadratic formula and then see if we have time to go back and do it by factoring. And you can decide which one would have been easier for you. So x is equal to negative b. Go ahead and kind of go through the formula as we do it. So negative b becomes not negative 5, negative 5. See where those parentheses came in handy, sorry. X is equal to negative b plus or minus the square root of b squared. It's negative 5 squared, but it is not negative 5 squared. I need that negative to be squared for it to be right. Minus 4 times a, which is 6, times c, which is negative 4. Those parentheses come in handy. All divided by 2 times a. So what can we simplify here? Well, I'm definitely going to simplify those to the exponent and kind of this whole multiplication problem. So kind of all the, I have 1, 2, 3, 4 different sections we could simplify. Negative 5 becomes positive 5, plus or minus the square root of negative 5 squared is 25. Now here I have two negatives multiplying to make a positive. 4 times 6 is 24. 24 times 6 I think is 96. All divided by 12. So x is equal to 5 plus or minus the square root of 121 all over 12. And here's where people will just circle it and be like, sweet, we're done. But I'm going to encourage you that actually you can do the square root of 121. So you have to simplify the radical. Once you've added them, you have to simplify the radical so that we get 5 plus or minus square root of 121 is just 11. Once again, I'll have people to do the quadratic formula and leave their answer like this. It's not right because you can actually add 5 plus 11, 5 minus 11. So 5 plus 11 over 12 would be 16 over 12. Would be dividing both of those by 4 4/3. And 5 minus 11 over 12 would be negative 6 over 12, or negative 1/2. So that's the quadratic formula, and I'm once again going to argue that is not going to be our easiest format. This would have been way easier to have taken our formula and done 6x squared, split the middle term. I'm going to put the negative first. Out of the first two comes a 2 and an x, leaving us with 3x minus 4. The second two already are 3x minus 4, but we put out a plus 1, leaving 3x minus 4. So my two groups are what they have in common, what they don't. I can solve this by setting each of these equal to 0. 3x minus 4 equals 0. 2x plus 1 equals 0. So that x is equal to 4/3, and x is equal to negative 1/2. That would be easier for me. You don't have to. We're giving you a set of tools, but if it can factor, that would be the way I would solve it. Here's example 2. 4x squared equals 8x minus 1. Our first issue, we said that this has to be in standard form set equal to 0. So I need this set equal to 0, which means I need to move the 8x and the minus 1. Technically, I could have moved the 4x squared, but I like to keep that a positive when at all possible. But now it's in standard form. Ax squared plus bx plus c equal to 0. So, can this factor? Well, I would check. AC, 4 times 1, negative 4 there. Is there something that multiplies to make negative 4, combines to make an 8? 1 and 4, 2 and 2. Factoring fell apart, but I would still check. 2. I would complete the square on this. In fact, I wouldn't necessarily. This is a little terrifying because of that 4 at the beginning. It makes it look kind of scary. But if I were to factor out that 4, if I was to divide everything by 4, the middle term would still be even. So I would argue this is still going to be easier by completing the square. But since this section is quadratic formula, let's go ahead and do that. X is equal to negative b, negative a, b, and c, so negative 8, plus or minus the square root of b squared, minus 4 times a times c, all divided by 2 times a. X is equal to. Simplify each of these groups. Positive 8 plus or minus the square root of 64 minus, now two negatives make that positive. Is that just 16? 4 times 4 is 16. All over 8. X is equal to 8 plus or minus the square root of 80 all over 8. This is where the quadratic formula can kind of stink. I have to simplify the square root of 80. So I'm going to take that square root of 80. Go, well, 8 times 10. 2 times 2 times 2 for the 8. Times 10 is 2 times 5. Pull out groups of 2. So really I have 8 plus or minus 2 2's come out, so 2 times 2 is 4. Square root of 5 all over 8. And this technically still isn't right because it has to be simplified. 8, 4, and 8 are all divisible by 4. I would recommend just splitting it actually. I would make this 8 over 8 plus or minus 4 root 5 over 8. 8 over 8 is 1 plus or minus, since these are both divisible by 4. That would be root 5 over 2. And that would be our answer. Now, once again, technically the homework will write that as x is equal to 1 plus root 5 over 2, and x is equal to 1 minus root 5 over 2. This, to me, is not the easiest way. What would I have done? I would have taken this and completed the square. And I don't expect most of you to do this, but there are going to be ones where you have to know how to complete the square. If you're going into the trigonometry and pre-calculus, you better pay attention to this because you have to be able to complete the square on these. So once again, if I want to complete the square, I want an a of 1, which means I'm going to divide everything by that 4. I generally remove the c first, so I'm not going to skip steps. Let's move the c. Then I'm going to divide everything by 4. And this one's actually not too bad, because what? Well, the a is a 1 and the b is even. So when I go to complete the square, negative 2 divided by 2 splits up nicely. That's that halved. What do I need to add to both sides? Negative 1 times negative 1? Positive 1. On the right, don't let the arithmetic complicate it. Negative 1/2 plus 1 with a common denominator would just become positive 1/2. Now we can solve this. Mess up somewhere? That was a 1/4. Jeez. Sorry, 1/4 plus 1 would be 3/4. Now we would just solve this, because now I have a single x. I can solve this using inverse operations. I can square root both sides. X minus 1 is equal to the square root of 3 plus or minus the square root of 3 over 2, adding the 1, x is equal to 1 plus or minus the square root of 3 over 2. So why aren't these the same? What happened? Did I miswrite this? 4x squared minus 8x. This was supposed to be a plus 1. Probably all you're screaming at your screen while I was doing it. Plus 1, plus 1. So the c is plus 1. Jeez. So all that did is change this to a minus 16. Sorry, I'll change colors so we can highlight my mistake. This was supposed to be plus 1. Changes that, which changes that. This would be the type of thing that in class you probably catch me. 64 minus 16 is not 80. That would be 48. So then, square root of 48 is not 80. It would be about 8 and 6, 2, 2, 2, 2, and 3. So the 4 still comes out, but it becomes 4 root 3. So 4 root 3. So root 3. Root 3. Root 3. Okay. So, sorry about that. Okay. So root 3, root 3. Root 3, root 3, root 3. Okay. Now the answers match. Ta-da. So keep in mind, this to me looks like a lot less work. There was a lot less simplifying of radicals. When you can complete the square, especially when you can do it simply, it is the easiest method. Okay. If you can factor, that's definitely the easiest, but then completing the square. Here's our next one, though. Kind of this last one I think is going to prove a good point here, because this one looks complicated. I could definitely move the 14x over, get it in standard form, so that 2x squared minus 14x plus 19 equals 0. Would I want to use factoring on this? AC, 2 times 19 is 38. And negative 14, what multiplies to make 38 combines to make 14. 1 and 38, 2 and 19. I think we're stuck. This doesn't work. But it's worth checking, because man, if this could factor, that could save us a lot of work. Second, would I complete the square on this? Probably not. Well, why not? Well, once again, this is not a 1. I could divide everything by 2. But that now 14 would become a 7, so it would no longer be even, which means completing the square really wouldn't be that easy. At the end, I'll show you where we can solve this by completing the square, but we'll see. Okay, so what am I going to do? Well, quadratic formula. It's kind of like a last resort. If factoring doesn't work, completing the square isn't really working easily, well then, let's do the quadratic formula. X is equal to negative b, negative 14, plus or minus the square root of negative 14 squared minus 4 times a times c, all divided by 2 times a Simplifying each group, x is equal to 14 plus or minus the square root of 14 squared is too far there, sorry. I believe it's 196 minus 8 times 19. 8 times 19, 80 plus 72, 152. 14. I'm going to double check that. I don't want to get too cocky here. 4 times 2 times 19. Alright, feeling a little cocky now. Alright, so x is equal to 14 plus or minus the square root of, I don't know, what is that, 44? All over 4. We have to now simplify the square root of 44. How about 4 and 11? 2 times 2 times 11. So out comes a 2. 14 plus or minus 2 root 11 all over 4. I would recommend, they recommend dividing top and bottom by the common factor of 2. I recommend splitting it, so 14 over 4 plus 2 plus or minus 2 root 11 over 4, and then simplify each one. So 7 halves plus or minus 1 half, or root 11 over 2. Oh, buddy. There's not really going to be any pretty way to solve this. This is where we really need the quadratic formula. It's going to make our lives a little easier than doing this by completing the square. But, to give respect where it's due, look, this is still solvable by completing the square. And those of you who are going to trigonometry and pre-calc, you actually need the skill. Because we're going to be doing stuff where we're going to have quadratic pieces, and we have to be able to complete the square to get them back into basically a shifting form or parent graph form. So you need the skill. If you're going into that, you need to know how to move the 19. So that 2x squared minus 14x equals negative 19. Make that a 1. X squared minus 7x equals negative 19 halves. Notice this is where I wasn't really thrilled to complete the square anyway, because I got to cut that 7 in half. How about 7 halves? What goes up here? Right? 7 halves squared, or 49 fourths. We're going to add to both sides. Don't let the arithmetic slow you down. Adding those with the common denominator would be negative 38 fourths plus 49 fourths. How about 11 fourths? And that's the most complicated part about completing the square. It's just the fractions and the arithmetic. Because once you have it in this form, it's actually very easy to solve it. Square root both sides. X minus 7 halves is equal to plus or minus the square root of 11 over the square root of 4 was 2. Adding 7 halves. What do we get? X is equal to 7 halves plus or minus the square root of 11 over 2. I would argue that this isn't really that much less work. It's just different. I don't have to simplify the radical in this one. I just have to deal with fractions. On the other one, I didn't have to deal with fractions as much. A little bit, but not as much. But I had to simplify radicals. So there's pros and cons to both of these. Our last little bit that we want to talk about is in the quadratic formula, there's a part that is called the discriminant. What it does is it discriminates. It's the same root word, discriminant. It discriminates. What does it mean to discriminate? You're like, I felt that was a bad thing. Well, not necessarily. But what you're meaning is what? To discriminate is to look at something and based on what it looks at, make a judgment call. Obviously, if we do that towards people, that's not cool, right? That's discriminating. You don't look at people and say, I'm going to judge you based on the way you look. We culturally don't appreciate that. But what we're saying in mathematics is we're saying, look, based on what happens in this b squared minus 4ac, based on what happens in the radical, I can look at that and it can tell me how many and what type of solution we have. We're going to look at it, and based on what it looks like, we're going to make a determination. Okay? We do that. You go buy a car and you walk up and you're looking at it and you're like, I'm going to discriminate. This car looks like crap. I don't want to buy it. Well, we do that. Okay? Don't do it to people. You can do it to cars. You can do it to math. Okay? So what happens if that b squared minus 4ac is positive? Well, it's after that plus or minus. So basically that gives us two answers. So if the b squared minus 4ac is positive, we have two answers. If it's 0, the b squared minus 4ac, if that all becomes 0, all of this just zeroes out. And all I'm left with is negative b plus or minus 0. That's just negative b over 2a. We end up with one solution. Specifically, our solution is just the negative b over 2a. And why? Because that whole thing's zeroed out. And what happens if it's negative? And this is still 1. Well, if we get the square root of a negative, then we have no real solution or two imaginary solutions. So the square root of a negative is not real. But plus or minus I, we do end up with two imaginary solutions. Okay? So we kind of have two different sections. If it's positive or it's 0, both of these answers are very real. Even if this one, negative b over 2a, that will be also very real. Okay? But the difference is, if it's negative, we end up with no real solution or two imaginary. One other little note, if it is positive, and I'm not as big on this, if you can tell me two real, two imaginary, one real, I'm good with that, okay? But in the homework, okay, if the square root of n is a whole number, so if it's like the square root of 4, or the square root of 9, or the square root of 16, if you can get a whole number out of it, we call that rational. If it's radical, like the square root of 5, the square root of 2, square root of 11, where it cannot be simplified, we call it radical. Okay? So we'll talk about that. That's kind of our last little topic. It's not too big of a deal. Here's a couple questions. I've messed with the A, B, and C. But I want to determine the number and type of solutions. All I really have to look at is the b squared minus 4ac. What I recommend, where people seem to be a little more successful with this, is you could take the whole thing. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. X is equal to negative 3 plus or minus the square root of 9. What is that? 16 times 2 plus 32. All over 4. X is equal to negative 3 plus or minus the square root of 41 over 4. I could answer this question. How many solutions are there? What type? Well, all I really need to look at is this. Because there's a square root of 41 there. That 41 is positive. So plus or minus a positive number is going to give me two real solutions. The b squared minus 4ac is 41, which means it is positive, which means that there are what? We said two real solutions. The homework might go a little crazier with that, where they're like, well, the square root of 21 or 41, can it be simplified? Well, no, not really. There's no whole number that comes out of that. So they would call this two real and radical solutions. I'm not as concerned about that. Don't make any basket issue out of that. But just make sure, once again, I only really need to look at the discriminant to figure out how many solutions there are. And I can see at the end that we have two radical solutions. On this one, I don't have to look at the whole thing, but I could. X is equal to negative 3 plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. X is equal to negative 3 plus or minus the square root of about 9. This time that's minus 32 all over 4. x is equal to negative 3 plus or minus the square root of, is that negative 23? I can see the solutions here because I now would need to try to simplify the square root of negative 23. This is really all I need to look at. I can discriminate. I can tell how many solutions are going to be just by looking at the discriminant. The b squared minus 4ac, the discriminant is negative 23. Therefore, if it's negative, we're going to have none, no real solutions, or 2 imaginary. And I'm not exactly sure how they're going to handle that in the homework. I would prefer 2 imaginary because we are going to actually be getting imaginary solutions out of these, and we're going to write them as imaginary, so I'd prefer that. But 0 real, 2 imaginary. Last but not least, x is equal to negative b, negative negative 8, plus or minus the square root of b squared, minus 4 times a times c, all divided by 2a. X is equal to 8 plus or minus the square root of 64 minus 64 all over 8. X is equal to 8 plus or minus the square root of 0. Well, hey, what did that do? I can discriminate. I can just look at that 0. If that b squared minus 4ac is 0, then that means that there will be 1 solution. Why? Because that basically just goes away, and I'm just left with 8 over 8. We get the answer 1. The plus or minus of 0 doesn't create more than 1 solution. So if that b squared minus 4ac is positive, 2 real solutions. If it's negative, no real, which means 2 imaginary. And if it's 0, 1 solution. Keep in mind, for all this to work, this still has to be in standard form. So they're going to have some questions where you have to put that in standard form before you can fill in the b squared minus 4ac. But that's nothing new, so I just want to make sure we go over this. That's it for the first section. So not too bad. Keep it up. Chapter 11, topics are a little harder, but that's why we're taking it slower. So keep up with the work.